I got my driver's license last week and I'm so excited. I'll finally go to my college by my car. Hey mom, I'm going. आज Sunday है.
Taking shots at the enemy.
Yeah, but I have my physics class today. Physics extra class. कार चला के जाओगी? Yeah, mom, of course. I'm an adult now. And this is the proof. I have my driving license. बेटा अब हम फ्रेंड्स हैं, राइट? तुम सारी बातें मुझसे कर सकती हो. Really, mom? यार कॉलेज नहीं है आज, मुझे तो कार चला के दिखाना सभी फ्रेंड्स को. पूजा के पापा सुनते हो? देखो बेटा, मैं तुम्हारी माँ हूँ, मुझे तुम्हारी बहुत फिक्र है. तुमको कार चलाने से पहले सब आना चाहिए. बैठो सामने, मैं समझाती हूँ. Now your car is moving with a uniform speed of v and you see a roundabout. So you try to move around it in a circle of radius r. Can you tell me what will be the acceleration of your car? Mom, this is not fair. V square by r. This is the centripetal acceleration which will be directed towards the center of the circle. And better, from Newton's second law, you know that force is mass into acceleration. So the centripetal force providing the centripetal acceleration is, let me write it as Fc. This is mv square by r, where r is the radius of the circle in which your car is moving, v is the speed of the car, and m is the combined mass of you sitting in the car and आपकी पापा की कार. And the direction of the centripetal force is the same as that of the centripetal acceleration, that is, it is directed towards the center of the circle. Such minute details were not required. अब बेटा सड़क हर जगह एक जैसी तो होती नहीं. So if your father's car is taking a circular turn on this horizontal road, which force provides this centripetal force? फ्रिक्शन. बेटा कॉन्फिडेंस कहाँ है आपका? जोर से बोलो, जय माता दी. बेटा दिमाग तो बहुत है आप में, यूज अ बिट ऑफ इट है. बेटा, if this is your car, what are the various forces that will be acting on this car? Weight of this car, that is mg, in the downwards direction. Then we have the normal reaction force, which is equal in magnitude as this but opposite in direction. This will be the force on the tires of the car because of the level road. ठीक है? And the third force that will be acting is the force of friction. Now the point to be noted here is that the centripetal force required for motion in a circular path is along the surface of the road, and the component of the contact force which is acting between the tires of the car and the level road on which this car is moving, the component of the contact force which is parallel to the surfaces, to these two surfaces in contact, is nothing but the force of friction, and it is this frictional force which provides the necessary centripetal force. Mom, is this kinetic friction or static friction? Beta, when you are moving around this roundabout, the tires of the car, they have a tendency to skid in the radially outwards direction, like this. The tires of the car have a tendency to skid in this radially outwards direction. But note that the car is not actually skidding. The car is not actually moving like this. It is moving like this smoothly. So this impending motion of the car tires moving away from this circle, this impending motion is what is opposed by the force of static friction. So this force is the force of static friction, not kinetic. Now look over here. So this centripetal force is provided by this force of static friction. So what can I write? This mv square by r is equal to this force of static friction. But you already know that this force of static friction has some maximum value, limiting value. So this force should be less than equal to mu s times n, where this mu is the coefficient of static friction and this n is nothing but the normal reaction force or the component of the contact force which is perpendicular to the surfaces in contact. ठीक है. So what can you get from here? This v square is less than equal to r by m into mu s times n. Another thing is that since there is no acceleration in this direction, this n, this normal force, actually balances this weight of the car so that n is equal to mg, right? And you can put the value of this n by m from here into this expression. So you will be getting v square is less than equal to r mu s into g. R is the radius of the circle in which the car is moving. G is the acceleration due to gravity. And this means that this expression is independent of the mass of the car. माम आप ये सब क्या कर रहे हो? बेटा मैं इन सब से आपको ये समझाना चाहती हूँ कि for a given value of mu s and r, the maximum speed with which you can move in a circle is for the case of level road. तो बेटा ये मैक्सिमम स्पीड है लेवल रोड पे सर्कुलर टर्न लेने की. और अगर इससे तेज स्पीड से तुमने कभी कार चलाई तो सच बता रहे हैं बेलन लेके तुम्हारा सिर फोड़ देंगे. ओके ओके रिलैक्स रिलैक्स. अब बेटा सड़क हर जगह एक जैसी तो होती नहीं. मम्मी आप पहले भी बोल चुके हो. ठीक है बेटा चुप हो जाती. पहले इन्हें बोलना सिखाओ, पाल पोस कर बड़ा करो, फिर ये बताएंगे हमें कि हम कितना बोल गए. मम्मा सॉरी. अच्छा मम्मा सड़क पहले वाली लेवल थी, अब वाली कैसी है? हाँ तो बेटा नाउ आई विल टेल यू अबाउट द मोशन ऑफ द कार ऑन अ बैंक्ड रोड. मॉम मुझे मौत के कुएं में कार थोड़ी चलानी है. तो बेटा तुम अपने पैरों पर खड़ना सीखो. इन दिस केस द प्रीवियस केस द एंटायर बोझ या बर्डन to provide the necessary centripetal acceleration was on this force of static friction. Only this force was responsible to provide the necessary centripetal acceleration. However, if the road is banked, the road around this circular roundabout, इस road की बात कर रहे हैं, if this road is banked like this at some angle say theta, the contribution of the static friction to the circular motion of the car can be reduced. चलो झूठे. So in this case, what are the forces that will be acting? Let us see. So this is the car. Because the road is banked, the car की position will be this, not this. This was horizontal level road. Now that the road is banked, so the position of the car is this. Again, the first force that I will be writing here is the weight mg of this car in the downwards direction. Then we have the normal force because of this banked road on the tires of the car. So this will be in this direction, the perpendicular direction. The perpendicular direction to the surfaces in contact. And the force of friction that will be acting like this. So this is nothing but the components of a contact force which will be acting like this. The component parallel to the surfaces in contact will be the force of friction, and the component perpendicular to the surfaces in contact will be the normal force. So the contact force has been resolved in two components. Now if I choose a coordinate system like this, the horizontal direction is this, the vertical direction is this, and I want all my forces either in this direction or in this direction. Now let me draw this again. This was the force of friction. Now this force mg, that is the weight of the car, is already in this vertical direction. So I need not worry about this. However, let us talk about the components of this force of friction and this normal force. So this was the force of friction. Now what I will be doing, I will be resolving this into the horizontal and the vertical components. Let us see how we obtain them. So this is a horizontal line. Now if I draw an imaginary horizontal line here, these two are parallel lines and this is acting as a transversal. Okay. So this angle is also theta, alternate interior angles. Okay. So that means that if this force is along this line, along this transversal, so what will be this? The angle between this and this is theta. So the component of this force in the horizontal direction is f cos theta. This is f cos theta. and the component of the force in the vertical direction is this, vertically downwards direction. This will be F sin theta. So this force F, this was this force, is resolved into two components, F cos theta and F sin theta. ठीक है. Similarly, we talk about this normal force, which was this. Okay, again you draw an imaginary line over here. You know that these two lines are parallel. This is transversal. This angle is theta. Alternate interior angles. ठीक है. And now you know that this normal force is perpendicular to this inclined plane or the banked road. This normal force is perpendicular to this. This means that this entire angle is 90 degrees. Similarly, this angle is also 90 degrees. So what is this angle? This is 90 minus theta. Now if I resolve this normal force into the vertical and the horizontal components, what will I get? This will be n cos of 90 minus theta. Cos of 90 minus theta is sin theta. You should know these trigonometric relationships. So this will be n sin theta, and this vertically upwards component will be n cos theta. This is the clean diagram. These are the forces which have been resolved in horizontal and vertical components for the case of banked road. Now you know that there is no acceleration in this vertical direction, so this n cos theta will be equal to this mg plus f sin theta. Note that in the case of the banked road, the horizontal components of the force of friction and the normal reaction force, the horizontal components, that is f cos theta and n sin theta, यही horizontal components थे इनके. So these two forces are providing the necessary centripetal force. I will be writing f cos theta plus n sin theta is equal to mv square by r. तो मॉम व्हाट शुड बी माय मैक्सिमम स्पीड इन दिस केस? देखा, आग लगी हुई है, मतलब इसे तेज ही चलानी है कार. सच बता रहे, तुम्हारी टांगे तोड़ देंगे इस बार. चलो तुमने पूछा है तो बता देते हैं. दिस फोर्स ऑफ स्टैटिक फ्रिक्शन शुड बी लेस देन इक्वल टू म्यू एस टाइम्स एन. इसका मतलब है कि म्यू एस टाइम्स एन मैक्सिमम वैल्यू है स्टैटिक फ्रिक्शन की, जहाँ तक ये आपकी हेल्प कर सकता है. इतनी ही वैल्यू तक ये आपकी इसमें हेल्प कर सकता है टू मूव इन अ सर्कुलर पाथ. द कंट्रीब्यूशन ऑफ द स्टैटिक फ्रिक्शन एट मैक्स कैन बी दिस वैल्यू. तो तुमने मैक्सिमम स्पीड पूछा है, उसके लिए मुझे ये फोर्स ऑफ फ्रिक्शन मैक्सिमम रखना पड़ेगा. यू हैव आस्क्ड मी द मैक्सिमम स्पीड, तो उसके लिए द मैक्सिमम वैल्यू ऑफ स्टैटिक फ्रिक्शन आई विल बी सब्स्टिट्यूटिंग इन दीज टू इक्वेशंस. So substitute this here and here. What you will be getting is now I will be substituting the value of this normal force which I have obtained from this equation 2 into this equation 1. So substituting n here, I will be getting now I'll be getting this expression, multiply the numerator and denominator by cos theta. Cos theta should not be equal to 0. This means that theta is not equal to 90 degree because we are talking about a banked road. For this case, let us divide this numerator and denominator by cos theta. So I will be getting which means that the maximum possible speed of a car to move in a circle of radius r on a banked road is this. तो मॉम, मैं राउंडअबाउट के अराउंड ज़्यादा स्पीड से लेवल रोड पे चला सकती हूँ या बैंक्ड रोड पे? देखा देखा, तुम्हारे दिमाग में सिर्फ यही चलता रहता है और फिर तुम्हारे जैसे लोग ये राउंड अबाउट क्रॉस नहीं करते, सीधा उसी में जाके बसते हैं और फिर माँ बाप को फोन आता है कि अपने टूटे फूटे बच्चे उठा के यहाँ से ले जाओ, कुछ तो टाइम बोल जाते हैं। क्या यही दिन देखने के लिए तुम्हें बड़ा किया है? मॉम मैंने वैसे ही पूछा था दोनों केसेस का कंपैरिजन। तो बेटा आपने पूछा है तो बता देते हैं। तो कंपेयरिंग दिस एंड this was the maximum possible speed to move in a circle of radius r for the case of level road and this was the case for the banked road. ठीक है, maximum possible speed है दोनों केसेस के लिए। So if we compare this and this, बेटा दोनों में से क्या बड़ा लग रहा है आपको? नहीं दिख रहा? अब यहाँ पे आप देखिए tan theta, when you talk about tan theta in the first quadrant, where theta can take values from 0 to 90, 90 को छोड़ के 90 से थोड़ी सी कम, because cos theta should not be equal to 0. We have used this approximation for the banked road. इसमें you put theta equal to 0, so this case reduces to this. Theta equal to 0 means tan theta is 0. So this is 0, this is 0, so this becomes this. This was the case for the level road. Now theta should be less than 90 degrees. तो we are talking about this first quadrant. तो अब theta की वैल्यू क्या है? यहाँ से it's from 0 to less than 90 degrees. So this is the first quadrant, and in this first quadrant tan theta is always positive. Sin is also positive, cos is also positive, tan theta is also positive in this first quadrant, which means that tan theta is positive. Okay. Now let us talk about this. So this is square root and you know that this should be real and positive. So I can say that this denominator, if I talk about this denominator, this 1 minus mu s tan theta should not be 0 and should be strictly greater than 0. So this should be greater than 0, which means that this mu s tan theta is less than 1. Mu s tan theta is less than 1. This thing is less than this. So if you compare this and this is mu s rg, this is mu s rg, the first term, and this is rg tan theta. R and g are positive. R is the radius, g is the acceleration due to gravity, and tan theta is positive in this first quadrant. So the numerator is of course greater than this term. Now talking about the denominator, mu s tan theta is less than 1. So you are subtracting something which is less than 1 from 1, which means that your denominator will be some decimal. Okay, and again this factor will result in the total Vmax for the case of banked road to be more than that of the level road. So this is greater than this. Now what if mu s is 0, the coefficient of static friction? Then what will be the case? Let me erase this. That is, if I put mu s equal to 0 here, I will be getting a velocity, say v naught, wherein this will be equal to square root of rg tan theta, simply this. Which means that if you are driving your car at this speed, the frictional force is not required to provide the necessary centripetal force. इसका क्या फायदा है? बेटा पैसे तो पेड़ पे उगते हैं, आपको हर बात में अपना फायदा देखना है, कभी अपने पिताजी का फायदा भी करवा दो। So driving at this speed will cause little wear and tear of your tires, and hence you can save a lot of money. अच्छा मम सॉरी, एक लास्ट क्वेश्चन, अगर मैं इस v0 स्पीड से कम चलाऊं तो? But beta, if you are driving with a speed say v which is less than this speed, this v is less than v0, what will happen? The tires of the car have a tendency to move in the inwards direction in this case. वो चाहेंगे कि तुम कार समेत चौक के अंदर जाके बजो. The tendency of the tires of the car for this case will be to move in the inwards direction, so that the force of friction in that case, in order to prevent this impending motion, the motion is about to occur but it is not actually taking place. So the force of static friction again comes into play, and now your diagram reduces to this situation like However, in this case, the direction of the force of friction will change to oppose this impending motion. For this case, the car has a tendency to move in the inwards direction, and to oppose this impending motion, the frictional force will act in this direction so that the car may not skid and smash into this roundabout. Again, you will be resolving your components. I hope by now this is clear. Draw an imaginary line here. This angle is theta. This complete angle is 90 degrees. So this angle is 90 minus theta. So this force of friction is this. You can see that these are parallel and this is acting as a transversal. These are the corresponding angles. This is theta. This is also theta. So what will be the components if I draw them here? This is n cos of 90 minus theta, which is sine theta, and this is n cos theta. This force is mg. This reduces to this. These are the forces which have been resolved in their respective vertical and horizontal directions. So what I get from here is again f sine theta plus n cos theta will balance this weight of the car, and of course n sine theta minus f cos theta will be providing the necessary centripetal force in this case. These two equations, and the car can be parked. For this case, if speed is less than this v0, the car can be parked. कार पार्क कैसे कर सकते हैं? If these two forces are equal, like n sin theta is equal to f cos theta, but you know that this f is the force of static friction. The maximum value that it can have is mu s times n, so this should be less than equal to mu s times n cos theta. This n is nothing but this. So which means that this n sin theta should be less than equal to this, and if you cancel this, which means that tan theta will be less than equal to mu s. And if this condition is satisfied, only then your car can be parked if its speed is less than this v0. v0 is the speed wherein you do not require any frictional force to provide the necessary centripetal force. Again, you should see that I have applied this approximation to obtain this. What does this mean? तो बेटा लाइफ में हमेशा बीच का रास्ता चुनो. चलो मॉम गोवा चलते हैं. ये लड़की हमेशा उल्टा समझती है. So that was all for today. I hope you liked my video. Do not forget to like, share, subscribe. You can also follow me on Instagram. I'll be back with my next video. Till that time, do not forget to take really good care of yourselves. Bye bye.